Welcome to my channel. In this segment, we will discuss the trapezoidal method for numerical integration. What is trapezoidal method? The trapezoidal method is a numerical integration technique used to approximate the definite integral of a function. It works by dividing the area under the curve into trapezoids and summing their areas. The basic idea is to approximate the curve with a straight line segment connecting the adjacent points, and then calculate the area of the trapezoids formed by these segments. Let us understand what I have said. Say a definite integral a to b fx dx. Here the black line curve is a function fx. Now we approximate this curve. I am drawing a straight line from a point to b point and approximating this curve by a straight line, and you should think like this way. A or b are very close to each other, so that's why you can think this part is the error part which is not covered under this curve. Or integration means the area under the curve, but I am just calculating the area under this red line, that means the area of this trapezoid. This is all about the trapezoidal rule. What is the area of the trapezoid? Half multiplied by sum of lengths of the parallel sides into perpendicular distance between the parallel sides. Now what is this? What is the length? This length is fa and this length is fb. That means half of fa plus fb and multiplied by distance between them, which is b minus a. And this is all about the trapezoidal rule for a single segment. And we can thought of as this as, and if we want to calculate the average of this function fx, we can say f average, angle bracket f means average of the function over the interval a to b, which is integration from a to b fx dx by b minus a. This is another way of looking at this. And if we put b minus a here, a to b fx dx, that is equals to half fa plus fb, that is equals to f average. Therefore, a to b fx dx can be thought of as average value of the function multiplied by b minus a. And there is another view of doing this. Basically, I am just fitting a straight line from this point to this point, from a point to b point. That means straight line is a first order polynomial of first order polynomial. Therefore, the function, the integrand here is approximated using a first order polynomial f1 x dx. What is f1? This is a straight line passing from a starting from a and ending at b. And what is the equation of this straight line? It is very straightforward, and fb minus fa divided by b minus a, this is the slope of this straight line, and that is x minus a, and this is the intercept plus fa. This is the straight line equation of this. Therefore, according to our proposal, and fx is replaced by f1x, and f1x is a straight line from a to b. Therefore, I am just putting that f1x into here, and which is what I have written here, fx dx is equals to, and it is here, that means fa plus fb minus fa divided by b minus a multiplied by x minus a dx. Now I integrate this, and this is very straightforward thing. Fa multiplied by dx integration, that means x, dx is x, fb minus fa b minus a, and here is x, that means x square by 2 minus a, and fb minus fa by b minus a, x, and dx is x. And after putting all these limits and simple algebraic simplification, you will get, I am just skipping this part, you can do by your hand. End of the day, you will get that thing, a to b fx dx is nothing but what I have got earlier, that is fa plus fb divided by 2 multiplied by b minus a. This is for a single segment. But now we want to integrate for a limit from a to b, which is not a and b close to each other. Here a and b is very far away, and therefore all these segments is all this area is divided into multi-segment, that means n segments. This is called the multi-segment generalization, and I am just using these results repetitively. And what is that? And here a, and another straight line is drawn, perpendicular straight line, which is dividing in a multiple segment, multiple partition. that is a, and this is a plus h is very small, and then a plus 2h and dot 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 the last, but this is the last one is b, which is a plus nh, and this is a plus n minus 1 multiplied by h. Therefore, I can safely do this a to b fx dx a plus h for this segment. This is the segment number 1, and then this integration is coming from a plus h to a plus 2h, a plus h to a plus 2h fx dx, and dot 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 a plus n minus 1 multiplied by h to b. This is the last segment 1 2 3 dot dot dot, and therefore I am collecting, and if we do this integration fx dx, we already know for a single segment this is the fa plus fb, one end limit a fa and another end fb by 2 by b minus a. Here it is very straightforward, which is fa and another one is fa plus h divided by 2 multiplied by h, and h into similarly fa plus h, fa plus 2h divided by 2, and all that way to fa plus n minus 1 h plus fb by 2. This is all about multi-segment or else n segment generalization of trapezoid rule. And now collecting all the terms, I collect h by 2 here, and that is fa is one time, but fa plus h and f h is coming twice, that is 2, and because h by 2 is coming out, so twice a plus h, and in the similarly 2 into fa plus 2h dot dot 2 into a plus n minus 1 over bar and b and fb, and fab is adding only 1 and intermediate points is adding twice, and we know h is equals to b minus a by n. I can also write in this way, h is replaced by b minus a by 2n, n is the number of segments, and I can generalize this part as twice of I equals to 1 to n minus 1 if a plus ih. I is coming from going from 1 to n minus 1, not the first point and last point is excluded. Or I can say h by 2 fa plus fb, and 2 is coming 2 is going out, therefore h multiplied by I equals to 1 to n minus 1 if a plus ih. This is all about n segment trapezoid rule. Now we are going to discuss in the next part, that is Python implementation as well as the much more advanced Numpy implementation. As we have discussed, this is the formula for trapezoidal method. A to b fx dx is h by 2, if a one of the limit and if b another limit, plus h multiplied by I is running from 1 to n minus 1, first point and last point is excluded, if a plus ih, intermediate points. First I am discussing the pure Python based implementation, then we use Numpy. So therefore I am defining some integrand. Here I am very simple integrand, that is x, that is fx is x, very simple thing, and so define a function fx which returned x, which is the integrand, and now we define a function trapezoidal method, trapezoidal, which requires f, the one limit, another limit, and number of segments. Now we calculate the segments, h equals to b minus a divided by n. First we calculate the value of the integrand. For the first thing, that is h by 2, h is multiplied by 0.5, fa plus fb. Now I run the loop for I equals to I in range 1 to n, because n is not included here, because in Python range is always the last point is repulsive. So 1 to n, that means basically n minus 1, and run integrand in t, that is already the sum is there, and after that h multiplied by fa plus ih. Very straightforward implementation, and I am not printing h, not required, and return int. Now I am calling, I am setting a equals to 0, b equals to 1, and n equals to say 50. So I am calling the function trapezoidal, print trapezoidal, f the function, and a is the one limit, b is another limit, n is the number of segment. I am run this. I am running this, I run this, and therefore the integrand, the value of the integer is 0.5 because x is x square by 2, 0 to 1, that means half. Very simple and straightforward, and you can increase the number of points, and so that this is a very simple implementation. Now we can also use the Numpy like this way. Import Numpy as NP and define function fx and return x like before. Now a is 0, b is 1, say n equals to say 11, and now we define x and h is something like that way, and np dot linspace a to b, a, b and n is the number of segments, and return step true, that means the difference between the 2 points will be returned, and you can see print x and print h. You can see what is doing this code. That means it will create array of numbers from starting from 0 to 1 with that is and h is 0.1, that means the spacing between 2 points is 0.1, and it creates how many points, that means 11 points, 0 1 2 3 4 5 6 7 8 9 10, that means 11 points have been created, and therefore as the points are created, and now we can suppress this, and now I create a function now I create some array I, which is a function just x is created a array, so therefore this function the function is computed at different values of these array points, that is stored in another array, that is I. That means f and x, the argument of this f is basically x. The x is an array, that means this function is called, and each array points this function is computed and stored in I, and you take the print of I, and you will get that thing. And that is same because it is x, and if you make it x square, then it will be very much easy to understand what is basically I is. That means that's the square of these things, and this is all about I, and this is your say what is x side by side, this is your x, and this is the next second line is that is the square of these things, but I am now integrating only x, so I am just what is I and what is x, I hope it is clear. I is an array containing the computing the value of this function at different values of x. Now it is very simple, h into multiplied by 0.5 because h by 2, fa and fb the first value and the last value, it is directly called, and plus h star np dot sum, it will sum from I 1 to n minus 1 because last point is excluded. What is the reason behind this n minus 1? Just you check it, and what is I am just take the printout of I, and what is I 1 to n minus 1, and you will look at it, and this is your I from 0 to 1, that means all the points, but 1 to n minus 1 means the first point 0 is excluded and the last point 1 is excluded, that is my 0.1 to 0.9. So that's why 1 to n minus 1 sum of the middle points as per the trapezoidal rules. Therefore just you suppress this and take the printout of this integration, and you also suppress this is 0.5, and you can make it much more, say 100 points, and it is very easy integration, so therefore this is a 0.5. That means 100 points is one line, that is basically the 2-line implementation of trapezoidal rule. Thank you for watching. If you have any query, and you can post a comment, and please like, share and subscribe. Thank you for watching.